Okay, this tutorial is going to deal with solving equations, systems of equations using the elimination method, but we're going to do a more complex example than we did in our previous examples. One where you have to multiply both equations by a coefficient. So this would be using elimination to solve a system of equations. And this is a little more complex. Example. Okay, we're still going to be using the same method that we looked at in the original examples that we did in the last tutorial. But in this tutorial, what we're going to do is we're going to use a little more complex example. So let's say we had 2x plus 3y is equal to a negative 6. And also I had a 5x minus 2y is equal to a negative 15 for my second equation. So I wanted to show you an example where, well, not always can you multiply by a nice round number to make it turn into y, because sometimes the linear equations will have coefficients in front of both the x and y in both of the equations. In that case, you have to just multiply both equations by their counterparts. So doing my analysis, I think to myself, well, the x's are the same coefficient. The y's are opposite coefficients. So simply put, I want to eliminate y because of their opposite coefficient. So I eliminate y is going to be my goal. So what do I have to multiply by in this equation, A, and this equation, B, to make the y's the same number? Well, basically, you take the 3 from this equation, multiply it over here, and take the 2 from this equation, multiply it over here. Just make sure that you don't use the signs so that you keep them both positive so that the signs will stay opposite. So basically, I'm going to multiply equation A by 2. And I'm going to multiply equation B by 3. So I'm just taking those coefficients that are in front of the y in the other equation and multiplying them out. So let's do that. So let's do A first. So I want to take 2 times 2x plus 3y equals negative 6. I'm going to work it out here on the side. So that's going to give me a 4x plus 6y equals negative 12. Okay, then I'm going to do the B equation now. I'm going to multiply it by 3. So 3 in front of the B equation, which is 5x minus 2y equals a negative 15. So moving it over here, 3 times 5x is 15x. 3 times negative 2y is negative 6y. And 3 times 15 negative is negative 45. So the next step then is to add the equations. To eliminate this y here. 4 and 15x gives us 19x. And this would end up giving us negative 57. Solve for x. Divide by 19 both sides. 57 divided by 19 is 3, so that'd be negative 3. Okay, so we have that. Now we can solve for y by going to our original equation. Find y. given we know that x is going to be negative 3. So I'm going to choose equation A. 2 times a negative 3 plus a 3y is going to give me a negative 6. Just going to check to make sure that that's in our field of view. I'll maybe move it up a little bit so I can finish working it out. Work it out there, I get negative 6 plus 3y is equal to negative 6. Add 6 to both sides, we get 3y is equal to 0. Divide by 3, we get y is equal to 0. So then we have a result of negative 3 and 0 is our result. Well, let's check them in the equation to see if it works. So I'm going to use the other equation. 5 times negative 3 minus 2 times 0 equals negative 15. So that works. So there we have an example that's a little more complex. Sometimes when you have odd coefficients that don't give you nice multiples of each other, you have to multiply both equations by a certain value. Our next tutorial will be dealing with the substitution method.